Okay, so today we're going to take a look at section 8.1, direct variation and proportion. The idea of direct variation is, simply put, as one thing changes, the other will also change. Okay, so for example, if you think about a common sense example, from, let's say, the time you're like 1 year old until you're about 7 years old, as your age increases, your height increases. Now, obviously, your height will stop increasing once you get older, but the idea that as one increases, the other increases. And the formula that we're going to use today is y equals kx, which tells us k is the constant of variation. Now, in a minute, we're going to talk about this, and we're going to also call it the slope, okay, the slope. Because if you think about it, this is like y equals mx plus b, but there's no b value here. So direct variation, again, as x increases, y also increases. Let's take a look at it. So for our first example here, we're going to see we have y varies directly with x. Okay, y varies directly with x. When the value of x is 4, the value of y is 24. Find the constant of proportionality. Again, this is another word for the constant of variation here, proportionality, just so you see both. Then find the value of x when y is 18. So we have y varies directly with x. We know that when the value of x is 4, the value of y is 24. Find the constant. So we're finding k. So let's solve this for k. So divide by x, we get k is really just equal to y over x. So the constant of proportionality, or constant of variation, is simply going to be 24 over 4, which is 6. Now, what that tells me is that we have the following function, really, or the following relationship. Y equals 6x. And this is very similar to our linear functions. It is a linear function. We're seeing it's a linear function with a slope of 6 and a y-intercept of 0. And at this point, what we want to do is say, okay, find the value of x, right? Then find the value of x when y is 18. Well, if y is 18, just plug it in. Okay? So we'll notice that x went from 4 to 3. Well, why did it decrease? Well, y went from 24 to 18. And notice, 24 over 18 is 4/3. There's the proportion set up. Again, this goes by a factor of 4 to 3. This is also a factor of 4 to 3. Now, for the next example, it says, the paycheck for a salesman, P, varies directly with the number of hours worked, W. When the salesman works 12 hours, his paycheck is $96. What is his paycheck when he works 17 hours? Now, you can use common sense and just find an hourly rate and then multiply it by 17. That works, but this is direct variation. Okay, so let's take a look. We've got the paycheck P varies directly with the amount of hours worked, W. So P equals KW. Okay, it says when the salesman works 12 hours, his paycheck is 96. So when he works 12 hours, his paycheck is 96. So the only thing we can do right now is find K. In a minute, we're going to say, okay, what if W is now 17, but we don't know yet. We need to find K. If we divide by the sum of both sides, we're going to get K equals 8, which is really saying, just as a side note, the hourly rate is $8 per hour. Okay, it's obvious because the units of P are dollars and the units of 12 are hours. So you take the units of dollars divided by the 12 hours. When you divide through here, you get dollars per hour. So that's the hourly rate. So we can just multiply that by 17 because we know how to do that from work experience. Or we can go back and say this is K. Now this formula up here simply becomes P equals 8W. Now again, 17 hours are worked. That's W, the amount of hours worked. So this is really just P equals 8 times 17. Okay, so we get a total value of $136. All right, so example 3 is a little bit different. It's still direct variation, but it's a bit of a variation of direct variation, no pun intended. So it says, if A is directly proportional, remember, varies directly proportional to B cubed, and A is 10 when B is 2, find A when B is 4. All right, so now it's direct. So A is directly proportional to not just B, but B cubed. So that's our new formula here. So you can have direct proportional. You can say something is directly proportional to the square, to the cube, to the square root. All you have to do is change that value over here, whatever it turns out to be. So in this case, that's what we have. And we're told that when A is 10, B is 2. So for a problem like this, we can just go ahead and solve for k. So 2 cubed is really just 8. Okay, so this is like an 8 over here, so we're going to get 10 over 8 for k. All right, we can leave it as a fraction, we can write it as a decimal, but personally, it's like a slope almost, so I would kind of leave it for now. So now we have this relationship. Okay, so again, remember, take your k value and plug it back into the original up here, so you get the actual relationship. And now we want to know, find a when b is 4. So just plug in a 4 for b. Find a, so leave it blank, when b is 4. Well, 4 cubed is going to give us 64. And this is 10/8 times 64. Well, just reduce, please. 64 over 8 is just 8. So a turns out to be this 10 right here times this 8. Okay? All right, let's take a look at the last example here. Example 4. The period of a pendulum is directly proportional to the square root of the length. So let's write this. The period is directly proportional to the square root of the length. So instead of b cubed or x squared for the proportional to the square, this is proportional to, right, directly proportional to the square root. The square root. So directly proportional is the equals k part, and then this is the square root of L here. If a pendulum 64 centimeters long, that's L, has a period of 1.6, so we know L, we know P, we can plug those in right away. What is the period of a pendulum 100 centimeters long? So in a minute, we're going to have to find out what the period is, but we're going to have to know more information. So let's solve for k here. It's going to be 1.6 equals k times 8. Dividing by 8, we're going to get 0.2 for the k value. Okay, 16 over 8 is 2, so 1.6 over 8 is going to be 0.2. All right. Now, if that's the k value, let's go ahead and plug it in up here. Okay, so 0.2 square root of L. So in this problem now, we want to find out what is the period of the pendulum that's 100 centimeters long. Okay, make sure you notice our units here are seconds. The period of the pendulum was given in seconds earlier, so it's still in seconds.